Well, hello. So today we are going to be talking about 8W7 and the assignments that you have this week. We're going to start the stream here in about 11 minutes. Until then, I'm going to play a little game, waiting on people to log in. So stay tuned. So yes, we are going to be doing 8W7 practice problems because that's what the assignment is this week. I've had a lot of requests for people to, or for me to be working those problems out. So we will get right to that. But while we're waiting for people to join up, I'm going to turn some digital cardboard sideways. Okay, so. Hey, Jay, how's it going? Ooh, I think I want to edit that deck. It's just waiting on more people to join up. I'm just messing with the Brawl deck while we wait on more people to join. Let's see. Creatures. Rare. And then. No, I'm not sending you as my companion. Gotta take something out. Hydra maybe. What's that land situation at? Just lands. Yeah, let's try it like that. We have about 6 more minutes before people are going to join to do some 8W7 practice. That's going to involve some equations with variables on both sides and using parentheses and then determining how many answers there are to a system. Good stuff, good stuff. Okay. Wow, this end has no acceleration whatsoever. Maybe I need to put some in, but it does have a lot of removal. So sure, we'll try it. Huh. Okay. Show me a land. Nope, not a land. Come on, land. Well, that's kind of a land. So play you to next end the turn. I'll trophy something if it's absolutely backbreaking. Leave it on the battlefield. Otherwise, I'm just gonna let it go. Play me a lantern. Sure. And I will trophy that. I'm gonna ramp you and give you a land, but it's all good. What are you gonna do? I can't let your guy sit out. Ooh, it's a land. I gotta play this though, and I gotta pay you life to do it. Heavy lantern. Say go. This next turn. Let's see. Yep, nothing I knew about it. So what can I do with 4 mana? Hey, it's Peyton. Sweet. Good to see you, buddy. We're just giving everybody a few more minutes to log in and join up. I guess I'm just gonna scry one. Oh, that's a gain lifeline. Never mind. He's got one of those too. Okay. Nice synergy there. All right, I guess I'll play Yarok. Let's see how it goes. Hey, you're muted just in case you know that. If you need to talk to me, just change that. But if not, it's all good. Let's see. Guess I'll send you to the command zone. Play you. What's the plan? Guess I will play my Garruk. Make my 2 guys. Say go. That's not good. Why'd he come in as a 7/7? Don't know. Oh, he emblemed Garruk already. That's why. That's not good. One more minute, wait on people to join up, and then we'll get to it. Well, I think I'm super dead here. I just got to such a slow start, and these are just slamming planeswalkers. So let's just go ahead and 4, 1, 2, 3. All right, here's the math. So the 1, 2, 3, 4. I can steal one thing. Okay. Well, how do I not die this turn? That is the question. I guess I can steal Questing Beast and attack, then he blocks with both guys, and Garrett gets pumped. I'm gonna go ahead and stop this timer before it blares us with its siren. I think my game's over anyway. I can steal Garrook and make more guys, but then he just swings in, Questing Beast, and kills my Garrook. If I stole her, I'd make it do, but it wouldn't block. That's a tough one. Well, I guess I may have trampled. Goodness gracious. I mean, I guess I just steal the Questing Beast. I mean, I'm not sure that helps me live. All right, it's time. We're gonna get rolling because I think I'm super dead in this game anyway. I'm just gonna go ahead and concede. You got me, buddy. You killed my mana ramp and you got your planeswalkers first. I was not gonna catch up after that. Okay. So timer be gone. So what we are doing today, everybody. Get rid of you though. All right. So 8E7. Okay. So what we're talking about, just to state it plain as day, we're going to be doing some equations with variables on both sides. That's one thing we'll be doing. We will be doing some equations with parentheses. Like those are standard sort of tried and true calculations, but then something that's been giving people grief, and it should because it's sort of new. We're going to be determining how many possible solutions there are in a system. That's the other big thing we're going to be doing now. I don't think I'm getting that into one box. Okay. So these are our goals for the day. We're going to be doing equations with variables on both sides, equations with parentheses, and then determining how many possible solutions there are in a system. So if you have paper and pencil, get it ready. We're about to get started here and do some practice. I don't want to do the actual problems from the assignments because that's going to be for grades. So I'll be doing problems that are very, 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 very similar. Okay. So let's start with equations. Let's start with equations with variables on both sides. Shall we? I think we shall. Just grabbing a practice problem. 1 second. I don't know why I closed the window that had it ready. That would have been smart. I don't know if my mic can pick it up, but I can hear the garbage truck coming down the street. And thank goodness I put out the garbage last night. Otherwise, I'd be having this panic moment right now, like, oh my goodness, lay garbage. I don't know if anybody on stream or on YouTube later, the garbage is your responsibility, but that's quite a that's quite a sound to wake up to. You know it's your job if you didn't do it. Okay. So this problem that I'm about to pull over is really good because of the people that have gotten this one on their practice problems on Khan, 75% of the people have missed it. And I think that makes it a really good problem to try. So here it is. So it says solve for b, where it says 4b plus 5 equals 1 plus 5b. Okay. So the first thing you've got to do on your paper real quick, everybody, is just write it down. Go ahead and write down 4b. Let me do this in the color that the text is up top. This is equations of variables on both sides. Okay, so 4b plus 5 equals 1 plus 5b. Okay, so if you're solving for variables on both sides, and again, this is a good one because so many kids are missing it on the practice problems. The first thing I'm going to do is look for the ability to combine like terms, like anything with a b attached to it can be added. But on the left side, I don't see any like terms. And on the right side of the equation, I don't see any right terms. I mean, common terms. So no combining to be done yet. Okay, so now I'm going to start using inverse operations to get the b all by itself. Step one, since I like to have things always be positive, I'm going to go ahead and I'm going to subtract 4b from both sides. Now, the abstract rule that we are totally abusing right now is that, oh, speaking of abstract rules, I should have my math practice standards on screen. There they are. Okay. So right here, we're going to reason abstractly real quick. Just remember that anytime wrong tool. Let's try that again. All right, so anything being combined with its opposite is equal to 0, and anything divided by itself is equal to 1. So those are the two abstractions we're going to be using a lot of here. So the reason I'm subtracting 4b from both sides is because of this rule. 4b subtracting 4b makes 0, and that's what I wanted to happen. Now I had to do on both sides to keep the equation balanced. So the other inverse operation I can do is I can take away 1 from both sides. And that means that since 1 minus 1 is 0, here's what we end up with. So this makes nothing, and the math teacher term of endearment for that is they cancel each other out. 5 minus 1 is 4. Put on an equal sign. 1 minus 1 is 0. Now 5b minus 4b is just 1b. And to be honest, I am so lazy, I'm not even going to bother with a 1. So 4 is equal to b. So the answer is that b would have to be 4. If you wanted to go and check it, it's real simple. You just plug in a 4 wherever you saw the b at. Starting to get better with this little tool. All right, so 4 times 4 is 16. 16 plus 5 is 21. 5 times 4 is 20. 20 plus 1 is 21. It checks out. So let's see what else we did. We made sense of the problem. We persevered in finishing it because we were very precise with our mathematics. I think I like to consider the tool being this inverse operation and organizing our stuff with the equation, everything being lined up. I've modeled my mathematics. Now I've constructed an argument because I went back and I proved it right there. That's my constructed argument that I am right. And yeah, I think that was a really good problem. So that's the first one with variables on both sides that people that are actually doing their econ lessons for practice really didn't do so well on. Okay, here's one that of the people who have gotten this particular problem, 0 people have gotten it right. So let's clear all these out real quick. Okay, so check this one out. This one, like I just said, of the people that got this while trying to practice, no one has gotten it right. So here it is. Yeah, no one's gotten this one right. I'm answering your question, Sharvik. Okay, chat. It looks like Tayden, it's just the 3 of us. And anyone watching on YouTube, what I want you to do right now is pause the video, try this one real quick, and then unpause and see how it goes. Step 1 is just to write down the problem. So 2 minus 2n equals 3n plus 17. All right, I got one answer from chat. Let's see. So the first thing I'd like to do, I'd love to combine like terms, except it doesn't look like there's any terms I can combine right now on one side of the equal sign. So let's see, how do I keep this positive? If I add 2n to both sides, this would become 5n. If I subtract 3n from both sides, this becomes negative 5n. And I just prefer to stay positive with my variables if possible. So I'm going to go ahead and I'm going to add 2n to both sides. Now, since I need to get the constants on the other side, I have to take away 17. So yeah, I'll end up with negatives, but not with my variables. So I'll take away 17 from both sides. So that means since negative 2n plus 2n, again, my abstract rule is that anything being combined with its opposite makes 0. So those go away. And then 17 minus 17, those go away based on that abstract rule. Math practice standard number 2, reason abstractly. Okay. So where does that leave us? So 2 minus 17 would be negative 15 equals 3n plus 2n is 5n. And then these cancel. So yeah, I do end up with a negative value in the problem, but I just love having positive coefficients attached to my variables. That means this 5 is positive, and I like it that way. Okay. So I guess the next thing to do, if I want to get n by itself, like over here, I need to divide this by 5. And whatever I do to this side, I have to do the other side. The reason I had to do that, or the reason I would do this, by the way, is that other abstract rule, anything divided by itself is equal to 1. So basically, 5 divided by 5, that's 1n. So negative 15 divided by 5 would be negative 3. And then 5 divided by 5 is 1, so that's 1n. But I'm so lazy, I'm just going to get rid of that 1. So n would have to be equal to negative 3. Questions, concerns? The people that are actually here, anything? I think we'll do one more. one more for now of equations with variables on both sides. So I've got another one here where it looks like only one person got this one in their practice, but that person missed it. So still a 100% miss rate. Okay. So if you're in chat, try this one and get ahead of me. If you're on YouTube, pause it real quick, try this, see how far you get, and then unpause it and see if you get the same thing I did. Okay, well, step one is just to write this thing down. So 4d minus 4 equals 5, equals, come on now, 5d minus 8. 4d minus 4 equals 5d minus 8. Yep. Okay, so the next thing to do, I can't combine any like terms here because they're all different. Note, they're like on the left side there are no 4Ds and 5Ds and other things. On the right side, they don't have a variable to combine. So if I want to stay positive, I think the best thing to do is just to subtract 4D from both sides. Now, no one told me to do that. It's just my intuition because I've practiced. Chat on the last problem. I'll go back to it in just 1 minute. So if I subtract these, but also if I were to add 8 to both sides, I think we'll end up with a constants over here. Yep, that's what we want. Okay, so abstractly, let's see, 4D minus 4D is 0, and then 8, a negative 8 plus 8, they're opposites, they make 0. So what I'm left with, negative 4 plus 8 is positive 4. 5D minus 4D is just 1D. But I am so lazy, I don't usually even write the 1. So D just equals 4. And I could construct a viable argument by doing a little proofing here. So if I were to plug in 4 here and here, this whole side would become, okay, so 4 times 4 is 16, minus 4 is 10. And this whole side, four times 5 would be 20 minus 8. Ew, that equals 12. Hang on a second. I might mess something up. 4D minus 4D is 0. Negative 4 plus 8 is 4. 5D minus 4D be just 1D. 4D minus 4, 5D minus 8. Did I make a boo-boo? Oh, yeah, I did right here. Duh. 4 times 4 is 16. 16 minus 4 is 12. But hey, I proved it to myself. I critiqued myself, and then I made a viable argument against myself. So go me. No, that's right. I made this small, goofy error. All my calculation was fine. So D would be equal to 4. Yes. Okay. So the question about the last problem. Hang on 1 second. Let me pull it back up. Okay, chat. Just correct me if it was this one or not. Was it this one? I can't go back and check. Chat waiting here for me. Was it this one? Oh, was this one? Okay. So the question was, why did I keep going after a certain point? Okay. So I have to keep going until I figure out what B is equal to. That's the whole point. So if I have, 4b plus 5 equals 1 plus 5b. And then I take away 4b from both sides. And if I were to take away 1 from both sides, let's see what I get. 4b minus 4b is 0. 5 minus 1 is 4. Negative 1 and 1 makes 0. And then 5b minus 4b is 1b. If I clean this up, I just end up with 4 equals b. So this is the wrong one. Okay, well anyway, I still believe that the answer to this one will be 4. All right, what's the one you want to see? Here, chat. Can you type out what the problem was? Because I've got a bunch of them here, and I didn't commit to memory which one I did second, and I can't rewind my own face at the moment. Oh, you didn't write it down on paper? Let's see. Okay, well, I hope that helped then. If you're writing that on your own paper, or if you're on YouTube and you're like, well, why can't you just back it up? Well, we're doing this live, so there's no going back. Okay, so we're going to move on to the next section, which is essentially the same as what we were just doing, except there are going to be some parentheses in the equations themselves. So it's going to seem like we're doing the exact same thing, except there'll be one extra step basically added on. Here we go. Okay, let's start off with one that nobody got right. So those people that are actually doing their con lessons for practice like they should, nobody got this one right. I'm gonna put this on the screen, and then I'm gonna contact Ms. Gable. She was trying to call me. Just 1 second, everybody. So here it is. So take a stab at this just for 1 second. I'm gonna mute myself and see if Ms. Gable needed something immediately. 1 second. Okay, thank you for putting up with that for just a moment. All right, so the first thing you would do, and everyone that's on, if you guys are on Zoom right now, you should have a piece of paper ready to go. Always, always, always. So let's go ahead and write this one down. So 3 minus 2 parentheses 9 plus 2m in parentheses equals m. Okay. So the way we're going to proceed is very similar to what we just did, except we have to do some distributive property work. Okay. So the way the distributive property is going to work for us right now is that we have to multiply this term right here, this -2. It needs to get multiplied by both the 9 and it has to get multiplied by the 2m. So what we get left with is 3. Now -2 times 9 is -18, so -18. And -2 times 2m would be -4m. And so that's all equal to 1m apparently. Reading chat 1 second. Okay. So the next thing to do here, we can actually combine some like terms. I've been saying those words a lot, but it hasn't happened right here. These two things, they don't have any m's. They're just numbers. They're just constants. So 3 minus 18. 3 minus 18 is just going to be -15. Now the opposite, now if we want to get these m's over on the other side, the opposite of subtracting 4m is adding 4m. And I have to do that to both sides. So where do we end up? Well, 4m and -4m, these two things combine to make 0. So they're gone. And m plus 4m is 5m. So then the last thing we would do is we would just go ahead and divide both sides by 5. Because 5 divided by 5 is 1. So you'd end up with just 1m. -15 divided by 5 is -3. And to be honest, I'm so lazy, we don't even bother writing the 1. So -3 is equal to m. We can test that by going back and putting -3 here and here. So like if that was a -3, then that'd be -6. Because 2 times -3 is -6. 9 minus 6 is 3. So this whole bit right here would be equal to 3. -2 times 3 is -6. So you end up with 3 minus 6 equals -3. And that's a true statement. So yeah, it works. So we went back and so we made sense of the problem. We persevered in solving it. We used some abstract reasoning when we were doing our canceling out math. I constructed my argument and I proved it by going back and putting the numbers in to test it. That would be an appropriate tool. I've modeled all my math. I've attended to precision. And a lot of this I'm using from previous experience. So that, like, if this feels like a problem I've done before, it makes it much easier to proceed. Okay, let's do another one of these. Or there's parentheses involved. Trying to pick one that people tried on Khan and did not do well on. That was the only one. Let's try one of these. Yeah, this looks like a good one. Capture it real quick. Here it is. So the first thing you would do is write it down. So on your paper, chat, YouTube, everywhere, everybody that's listening to me, write it down. So that'd be 2s plus 4 equals 5 parentheses -4 minus 2s. For those of you on the replay on YouTube, go ahead and pause it now. See if you can come up with the right answer, or at least an answer you can check with mine. People in the stream, go ahead and try to get ahead of me. Whoa. People in the stream, work a little bit, get ahead of me, and then I will catch up to you and we'll see what is the correct response. Okay. Well, the first thing I have to do is take this 5, and I need to multiply it by both terms on the inside, right here and here. So this 2s is just going to have to wait. This 4 is just going to have to wait. 5 times negative 4 is negative 20. And 5 times a negative 2s would be negative 10s. Okay. So now, well, I guess what I could do is I could add 10s on both sides. And I could also subtract 4 from both sides. So what you get there is, let's see, 10s and negative 10s make 0. 4 and negative 4 make 0. Undo that. So basically, let's see. So negative 20 minus 4 is negative 24. 2s plus 10s, that's 12s. So now, if we just divide both sides by 12, that'd be 1s equals negative 2. Because these cancel, makes 1s. And negative 24 divided by, negative 2. So there's the answer for this problem with equations. They use parentheses. Okay, so now we're going to move on to the completely different side of your assignment, the completely different skill set. And if you'd watched yesterday's stream, you would have a sense of this, but just in case you didn't see it, I'm going to give you a quick demo on what we are talking about. Okay, so how many solutions are in a system? We're going to have to talk about some of these words really quickly before we move on to practice. All right. How many solutions are in a system? Well, the first thing we've got to talk about is this word. Solutions. And then we have to combine that with this word, system. How many solutions are in a system? Okay. So just so you and everyone listening is completely in the know, a solution is it's the XY coordinate where two lines cross each other. Okay? That is, you just have to understand that. That is an XY value where the two lines cross each other. The system The system is made up of lines that are in. These are lines that exist in the same coordinate grid, okay? So that means there are 3 different options, okay? So let me go ahead and draw a quick coordinate plane. Okay, well, it's not perfect, but there. Look at my pink coordinate plane, which means I have a y-axis and I have an x-axis. Simple enough, sure, okay. Now, let me just drop 2 lines into this system. There's one. And here's another. What I want you to notice is where they meet. Okay? They meet in one spot. So sometimes two equations will crisscross once. Okay? So understand that sometimes there's only one answer, and that's where the two lines cross each other. Okay? Now, there's another possibility. That you will get a line like this, and then you'll get a line like this. Now, the question here is, where do they meet? If they are parallel lines going in the same direction forever, will they ever cross each other? No, they won't. So sometimes in a system, sometime in the system, the solution is that there is no solution because they never cross. The lines are parallel. They go in the same direction, the same rate forever. They will never touch each other. So that's another possible answer. Here's the last one. So what if you had a line going like this, but then your other line okay, so now we've got these two lines very carefully drawn in my head. They are the exact same line. They go right over the top of each other. Everything is the same. So what we say when this happens is that they are infinite. All the x and y values of the blue line are the exact same x and y values of the red line. So it'd be infinite solutions. So those are our three. I am yawning like crazy. I apologize. So those are our three possible solutions. But of course, in your con lesson, you might be saying, well, I never saw these pictures. That's right. They didn't give you the pictures. They gave you the pre-algebra form of this, which is word sentences, or number sentences, rather. So let me show you what these look like in number form. I'm going to try and keep these. Hang on, not that. Okay, I'm going to keep that. So let me grab one of these questions. Okay, sweet. So here's one that nobody got right. I need more people to do these practice lessons to get them ready for their assignments, but I guess all I can say for now is thank you to those that do. Yikes, I gotta clear all those. That's distracting. Okay, so here it is. So I'm just gonna go ahead and tell you now the way we know our answers when we see them. Okay, so no solution time. It'll be no solution if after we work with this number sentence here, if we end up with something like 3 equals 10. That'll never work. Therefore, they will never touch. That doesn't make any sense. 3 equals 10 is nonsense. That does not make any sense. So exactly one solution, after we do all the manipulation and the distributive properties and all the inverse operations, if we end up with something like x equals 2, we're done. We solved it. We're good to go. That's the one place the two lines cross at that x value. Now, infinite solutions, what that's going to look like is when, after we work with this number sentence for a while, we'll end up with something like 13 is equal to 13. So we're going to start working with this right here. Let me draw it. I was letting that soak in. So now we're going to solve this equation, and we're going to see which one it appears to match up with. So the first thing I'm going to do is I'm going to write it down. That's -5 parentheses z plus 1 end parentheses equals -2z plus 10. There it is. -5 parentheses z plus 1 end parentheses equals -2z plus 10. Okay, so I got to do the distributive property here. I'll end up with -5 -5z plus -5 times 1 is -5. So let me back that up. Whoa, Peyton. That noise is startling. Peyton, I had to mute you because you're making a lot of background noise. If you have a question, just unmute yourself and say so. So -5z times z is -5z. -5 times 1 is just plain on -5. So equals -2z plus 10. Okay, now that I'm looking at this, I'm almost positive it's going to be exactly one solution, I think. But let's go ahead and finish. So if I were to add 5z onto this side, and I was going to add 5z onto this side, and if I was to take away 10 from both sides, so -5z plus 5z, again, that's our absolute constant. So that makes it 0. -2z, oh wait, oh sorry, 10 minus 10 is 0. Okay. So what we end up with, -5 minus 10 is -15. -2z minus 5 plus 5z would be 3z. Then if we divided both sides by 3, that means that z is equal to -5. To be honest, I don't even care what it's equal to. This just means that there's exactly one solution. So the answer would be B. Because it came out to z equals something, that means there's only one answer. We're going to try a couple more, and we're going to see if we can get some that have no solution or infinite solutions. So we'll see. So we'll grab a different problem. How about this one? All right, chat, I want you to try this without my help, see if you can get anywhere with it. If you're on YouTube later, feel free to pause it. So there it is, 12z. I'll go ahead and, while I'm saying it, I'll go ahead and type it out. This is 12z minus 6 plus 15z equals 27z minus 5. This may or may not be the last problem today. I'm not sure yet. One second while you're trying this. One of the parents responded on mine. I just want to let her know something real quick. So you have an extra couple seconds to try and figure this out. Actually, I should just. Okay, so let's see how many solutions this one would have. So I can combine the 12z and the 15z. 12 plus 15, that'd be 27z. So I'd have 27z minus 6 equals 27z minus 5. Oh, let's see. That doesn't, I think I know what this is going to be. So let's, if I just check this out. So if we were just to take away 27z away from both sides, my handwriting got all sloppy all of a sudden. If I were to take away 27z from both sides, let's see. So 27z minus 27z is nothing, and 27z minus 27z is nothing. So we end up in a universe that is trying to tell us that -6 equals -5, and I don't think so. So if we remember back to the demo a few minutes ago, if you're on YouTube, just click back and look at which one is which. When you end up with anything like this that doesn't make any sense whatsoever, that is your sign that there is no solution. If you want a more algebraic explanation for that, here's what really happened. I can get my colors to work. Okay, so this right here, this 27z, basically what that's saying is you got two lines. One of them is y equals 27z minus 6, and the other one is y equals 27z minus 5. And that means the slope of both are the same. Right here. The slope is 27 for both. And if their slope is the same, that means that they're parallel. And if they're parallel, they will never cross. And that's why there are no solutions whatsoever. Okay. Well, that's going to do it for today's practice session. I really hope this helps you guys with your assignments. If you complete your assignments today, I said by 3 at the beginning of the week, but I'll go ahead and check it later tonight. So if you just get your assignments done before I go to bed today, basically on Wednesday, I will post back some highlighted notes of letting you know which ones you can retry for to get them right. They are due by tomorrow for grades. That's Thursday at 3 p.m. So until next time, I'll see you later.